Okay, we are doing the second lesson in our exponential unit. This is 7.2. We're going to learn about scientific notation. Your learning target today, you are going to be able to apply properties of scientific notation. So scientific notation, what it looks like is a number, write this down, a number times 10 to some kind of power. That's always how it should look. Scientific notation is always timesing a number by 10 to some kind of power. So after you do that, just put little bubbles or lines under times 10 to the power. That's all scientific notation must look that way. Otherwise, it's standard form, what you're standardly used to. Here's the rules of scientific notation that you need to be able to apply today with our learning target. Decimals, you move decimals. Move decimals how the exponent tells you to. Okay? This should be positive exponent. And then under it, I want you to write negative exponent. Okay? Because the exponent is the boss in scientific notation. The exponent is the one that tells all. It's the boss of everything. If it's a positive exponent, you're going to move to the decimal to the right. So move to right. If it's a negative exponent, you move to, what do you think?
Forward.
You're so smart. You move to the left. And then I have this thing called numbers. The number is just what's before the decimal. And what I want you to write for numbers, I just want you to write one number to the left of the decimal. One digit or number to left of decimal. And then write an example because that looks really confusing. So I'm going to have an example and a non-example. Make that T-chart. Example and non-example. An example would be like 3.14 times 10 to the negative 4. As an example, there's one digit to the left of the decimal. And I'm timesing by 10 to some power. A non-example would be 31.4 times 10 to the negative 5. That's not in scientific notation because there's two numbers to the left of the decimal. You always need one number to the left of the decimal. So this has 2, that is not okay. This has 1, A-okay. 2, no, 1, yes. Do you see? So our next objective, we're going to write numbers from standard form, write it in the scientific notation. That means I need to have a number times 10 to some kind of power. So my steps, the first thing I do is put one number to the left of the decimal. Everyone box out left. One number to the left of the decimal. And then underline one number. That's really important. One number to the left. That's the main point of that statement. One number to the left. And then second, determine how many spots it would need to go to move. Okay? This is going to be our exponent, times 10 to the power. So determine how many spots it needs to move to end, right to the end. or to get to the original form. All right, the first one. Where do you think I should put the decimal? Between the fours, because I want one number to the left. So I would put it right there. That was step one. So now I can write 4.4 times 10, and then I need to say how many spots do I need to move. That's when I just count how many spots it would take to get to the end. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that positive or negative? Positive, because I'm moving to the right. So the what is that, billion, 400 million, would be 4.4 times 10 to the 9. That tells your problem solver, move your decimal 9 spots to the right, and you'll get that number. Okay, the next one, and you always include the non-zero numbers, unless there's a 0 in between them. This would be, where am I going to put the decimal? Right after the 4. So I look to see where's my first non-zero digit. Put the decimal there. 4.21 times 10, and how many spots to get to the end? It would be 3, 6, 9. 4.21 times 10 to the 9. Do another one. We don't have any other examples with the smaller ones, so I write this down, please. 0.0, 0, 0, 0, 0, 0, 0, 3, 0, 1, 4. Write that down. So there should be 1, 2, 3, 4, 5, 6 leading zeros. When I look at this, the first thing I think is, here's my first non-zero digit. I'm going to put a decimal right there. Do you see my strategy there? I look for the first non-zero digit and put the decimal right there. So it's 3.014. I include that 0 because it's in between other digits, times 10, and then how many spots to get to the end. If I'm right here, I go 1, 2, 3, 4, 5, 6, 7. Positive or negative? Negative, because I'm moving to the left. That's our first learning target. Being able to go from standard form and write it into scientific notation. Okay, these are just a couple more examples. Again, to go from standard form, I know it's standard because it's not times 10 to a power. So I just go to my first non-zero digit and put a decimal there. And then I count how many spots to get to the end. So I usually always write times 10, and then I figure out the exponent. So it looks like I need to go 1, 2, 3, 4, 5, 6, 7, 8, and 9 to the left. Negative 9. Okay? The next one, my first non-zero digit is that 3. So I rewrite this as 3.105 times 10, and now I determine my exponent. That's 3, 6, 9. Positive, because I'm moving to the right. Nope, because then your problem solver, so that's a really good strategy. If you just did 3.1 times 10 to the 9th, the person that would be simplifying that would say I need to move 9 digits. So there's 1, 8 placeholder zeros. So they don't know that it needs to be a 0 and a 5 there. They're just going to add tons of zeros. So 3, 1, and 8 placeholder zeros. Okay, so it's completely different. You need to include any non-zero digit, okay? Otherwise, the person who's simplifying it will just assume that they write zeros. So writing in standard form, you just move the decimal as many spots as the exponent tells us. So how many spots do I need to move this decimal? 5. To which side? Is it positive or negative? Positive means right or left? Right. So there's one spot. How many more spots do I need to move? Say 4.
4.
Right? Because if I move one spot, I have 4 to go, so I add 4 zeros. 3, 2, 1, 2, 3, and 4. Now the other strategy is you can count as you go. There's 1, 2, 3, 4, 5. It just to me looks messy that way. But you can do whatever works best for you. I like to just count to myself how many placeholder zeros. Okay, how many spots do I need to move this decimal?
5 to the left.
5 to the left because it's a negative. So here's 1 to the left. How many placeholder zeros do I need?
4.
4. So 1, 2, 3, 4, 2, 0, 4, 3. You see how I did that? Okay, we're gonna bump up the rigor level. Meaning they're gonna try to trick you today and give you a number that looks like it's in scientific notation, but it's really not. You have to remember to make sure that there is only one number to the left of the decimal. You have to remember that. And if there's not, it's not in scientific notation, and you have to change it. For example, 0.387 times 10 to the 9th. They're going to say, write this in scientific notation. Is it in scientific notation right now? No, because there's no number to the left. So I need to rewrite this. However, now my power changes. So the best way to do this, and some of you are going to develop the trick, I'm going to ask that until you develop it on your own, you're going to do it the old-fashioned way. My first strategy is I'm going to rewrite it in standard form. So the 9 says to move it 9 spots to the right. Here's 3 spots. How many more zeros do I need? 6. So 3, 8, 7, and then 6 zeros. And then you rewrite it. It's a lot of work, but it will never steer you wrong. So now I put the decimal where it's supposed to be. 3.87 times 10, and then you got to tell the problem solver, go 1, 2, 3, 4, 5, 6, 7, and 8. And there is a trick that you can, there is a pattern that you will notice, but I want you to notice it on your own. I don't want to give it to you. So my strategy, rewrite. Actually, I want to write, my strategy is actually standard form. Standard means this, I rewrite it big, and then I rewrite. Okay? Is this in scientific notation? There's 2 numbers. There should only be 1. So I'm going to rewrite this one. This says times 10 to the negative 5, which means 5 to the left. If I move 2 to the left, how many more to get to 5? 3. So I'm going to add 3 placeholder zeros and write all the non-zero numbers. Now I want my decimal right there, 1 to the left. So 1.298 times 10, and then I say, okay, how many spots do I need to move? 1, 2, 3, 4 to the left, negative 4. And last, now that's huge. What I just covered with you is huge, those 2 examples. You will definitely be utilizing that today. Okay, and then you have a couple comparing, and I think that I might not, I'm going to just hold off on the